Hello everyone, I am Disha Kya, CSE Cyber Security Department. Today I am going to discuss about the partial orders and as diagrams. Introduction to the partial orders and as diagrams. Partial orders are the relations that reflexive, asymmetric and transitive. As diagrams are a visual representation of a partial orders that helps to show the ordering of the elements. In a as diagram, elements are represented as a nodes and other relation as shown by a connecting the lines. Partial order definition. A partial order is a binary relationship that is a reflexive, antisymmetric and transitive. A reflexive means that every element is related to itself. Antisymmetric means if A is related to B and B is related to A, then A must be equal to B. A partial order relation is any relation that is a reflexive, antisymmetric and transitive. A total order reflection is a partial order in which every element is a set of a compare with every other element in a set. Transitive means that if A is related to B and B is related to C, then A is related to C. Partial orders are denoted as a S, where S is a set of a partial order relation. As diagrams provide a visual way to represent the partial orders. A partial orders on a set is an arrangement such as a certain pair of elements one to another. The word partial is used to identify the not every pair of elements. Hasse diagrams. Hasse diagrams are a type of a graph is used to represent the partial orders. In a Hasse diagram, elements are represented as a nodes or a vertices. The ordering the relationship is shown by a connect in the nodes with a lines. The nodes are connected by a lines or edges as to show the ordering the relationship. The diagram is drawn in such a way that no two edges are cross each other. Constructing the hash diagrams. To construct the hash diagram, they start by listing all the elements in a partial orders. Then they draw the node for each element. Finally, draw the lines connecting the nodes to the representing the order in the relation. Hash diagrams are the unique representation of a partial order set. They are often used to determine the minimal or maximum elements in a set. Hash diagrams are useful in analyzing the structure of a partial orders in a set. Example of assay diagram. Consider a set A, B, C, D with a partial order relation. The assay diagram of a partial order would be show the A, B and C in a partial line with a vertical line with a lines connecting the A to B, A to C and B to C. As diagram provide a clear and a representation of an ordering relationship. They are easy to understand and even in a complex set. Properties of hash diagram. Hash diagram are often used to visualize the structure of a partial order set. They eliminate the edges and focus on the essential ordering information. Hash diagram are partially useful to finite set with a small number of elements. Hash diagram may become a complex for a large set with many elements. In some cases, the diagram may not be accurately presented all the relation in a test. Minimal and maximal elements. In a partial order set, an element A is a minimal if there is no other element B such that B is a less than or equal to A. An element A is a maximal if there is no other element B such that B is a less than or equal to B. These elements are often represented at the top and bottom of the as diagram respectively. Chains and anti-chains. In a partially ordered set, a chain is a subset of elements where any two elements are comparable. An anti-chain is a subset of elements where no two elements are comparable. Chains and anti-chains can be easily identified in a hash diagram. Covering relations. In a partial order set, if A is a less than B, there is no element in a C such that A is a less than C, C is a less than B, then we say that B is covers A. Covering relation can be visualized in a hash diagram by drawing a line from A to B. Covering relation helps to understand the structure of a partial order. Lattices. A lattice is a partially ordered set in which every pair of elements has a unique supremum, least upper bounded, and infimum, greatest lower bounded. Lattices can be represented using the hash diagram where top element is a supremum and bottom element is an infimum. Lattices play a crucial role in a various areas of mathematics and computer science. Applications of assay diagram. Assay diagram are widely used in mathematics, computer science and other fields to represent the partial orders. They help to visualize the structure of relationship between the elements. Assay diagrams are particularly used in a formal concept analysis, order theory, and decision making. Assay diagram is a unique representation of a partial order in a set. Algorithm for constructing the assay diagram. To construct the assay diagram for given a partial order, one can use an algorithm such as a level planner algorithm. Algorithm involves determining the minimal and maximal elements, identifying, covering the relationship, and creating the visual diagram. Computer software like a graphic can also use it to generate the assay diagram effectively. Challenges in constructing the assay diagram. Constructing the assay diagram for large set can be challenging due to the complexity of ordering the relation. Ensuring the diagram is visualized, clear and easy to interpret require the carefully consideration of a layout and a structure. Comparison with other diagrams. Assay diagrams are similar to directed the acyclic graph but have a specific property related to the partial orders. Unlike general graph, assay diagram focus on ordering the relationship between the elements. Assay diagram are often more compact and structured compared to other type of graphs. Limitations of an assay diagram. Assay diagram may not be suitable for representing a non-partial orders or a complex relationship. Assay diagram are most effective for a finite partial order set with a manageable number of elements. Educational use of an assay diagram. Assay diagram are commonly used in the mathematics education to teach the concept of the order theory and set theory. Assay diagram can be aid the problem solving and critical thinking skill development. Further research and extension. Research in a field of partial orders and assay diagram continues to explore the new application and theoretical advancement. Further studies may focus on the algorithm for constructing the assay diagram and improving the various domains. Conclusion. Partial orders and assay diagram are a fundamental concept in the mathematics and computer science. Understanding the partial order and assay diagram is essential for a various field and a problem solving scenarios.